going back to performance, and there are, like I said, there are instances where there's companies out there that they think iParts are and iAssemblies are the answer to their prayers in terms of simple automation. Being able to quickly go to a table and change to a different iteration. And if you have multiple levels within your architecture of iAssembly, subassembly, subassembly, iPart, once again, that can impact performance. So how do you resolve that? I am one of those customers, Tom. I am in that situation. I have way too many iAssemblies. I have way too many iParts. How do I get out of this? Performance is killing us. We got to come up with a different plan. Well, here's what I have done. I have worked with a company previously. Let me see if I can pull this up. I worked with a company previously that what they wanted to do, or what we decided to do, was as opposed to them continuing down the path of using iParts and iAssemblies, we would leverage iLogic to do the same thing. Remember, iParts and iAssembly are very simplistic means of using automation, or including automation within your design. But if you do use iLogic and you do want to embrace design automation with Inventor, quite honestly, you don't even need iParts, okay? Because really, what do iParts do? It's a simple way of going from one iteration to another, right? And that's all. So if you use Logic to do in your project, you can do the same thing with iLogic and using the Inventor API. I can define a value. I can create a condition. If this, then do that. So I can create a condition where I can swap in and out components as necessary. So alleviating the need to use an iPart factory, I can just have these individual components out there in a folder somewhere, and then I can access that folder and then just grab the file in which I need, bring it in, removing the other one, and I've accomplished the exact same thing. But in order to get there, in order to do that, you have to then take your iParts and essentially break out each one of those rows in your iPart factory. So taking this table and then create an individual component that's representative of that row, and then that row, and that row, and so on and so forth. So how do I go out? How do I take my table that I've already created? How can I leverage that in order to create my individual components? Well, it's quite simple. A couple of things that you need to do. Number one, you got to go to your iPart and then you got to edit via spreadsheet. Okay, so what this will do is it will take that table that I opened up inside of Inventor, and then it will superimpose it, if you will, or add that information to an actual Excel spreadsheet. And then what I can do is I can save this out. I can save this out or export this Excel spreadsheet out so it's a standalone table. And then what I can do is what I've done in this example is I've created a couple of rules. This first rule inside of Inventor, or iLogic rather, essentially goes to that Excel spreadsheet that I just created. And then what I'm going to do is I'm going to loop through the Excel file until I find an empty row. But until I find an empty row, what I'm going to do is I'm going to capture those values from my Excel spreadsheet, whatever row and column they might be in, and I'm going to populate a parameter inside of my model. Okay, so if I go back over here to my Inventor model here, I have my user parameters that are representative of that code in iLogic as placeholders, and these are associated to geometry. So as I go through this, if I edit this once again, so it's going to pull that information out of the Excel spreadsheet, populate the parameters. I'm then going to update my file, and then I'm going to save that file out as a unique file. And then it's going to go to the next row, and then the next row, and then the next row until it finds an empty row, essentially creating the different iterations that exist within my iPart table. So this is a very simple way of taking an iPart that could potentially be of creating some performance issue, and then breaking it out to individual components. And here's the really cool thing about this is the simple fact that because I'm saving them out, I have all my features. So it's a native Inventor file that is fully editable. And the reason why I say that is simply because if you've ever worked with iParts before, and if I go back over here and go into my iParts folder, here's my idler wheel. If I go to my C20, you're going to see that I have these children here, but if I double click on any one of them to open them up, so here's that child, that iPart child. You'll notice here it is C20-40, but if you look in my browser, I don't have any features. It's coming across as a solid, a dumb solid. So I don't have any features that I control. I don't have any parameters that I can control. If you look at my ribbon here, I can't even create or add any information. I'm totally locked out. It's just a graphical representation of that row within my iPart. So what my iLogic does here, as we break them out so we have all the features available. So it's very simple for me to then manipulate or edit these as necessary going forward. So it gives me full functionality in terms of updating my models so I can revise them. I can stay in line with, if this is a vendor component and they make a design change, I can adhere to those changes as necessary as well. So, and then now that I have all those individual components out there, then I can use my normal logic just to swap those components in and out. So another means of doing the exact same thing that iParts and iAssemblies can do for us, but without the worry of having that impact to performance.